All right. Hello, students, and welcome to the summary session on the topic of integers. Now, we've already done, one short session for this chapter already. But before we move on to the next chapter, we just wanted to make sure that all of you are in line and with the concepts of this topic. So, in case there are any doubts in this chapter, feel free to ask today. Okay, because as I said, before we are moving on to the next topic, we just want to make sure that all of you are thorough with all the basic fundamentals of this topic of integers. All right, so Deepthi says, can everyone see? All right, so Deepthi is helping me out here. I don't need to ask anymore. Am I audible or visible? So give me a thumbs up, guys, and thank you, Deepthi, for that. Ankad. Nagendra says, hello. Sashmita, hello. Santosh, hi. Arka, I'm doing good. Arka, I hope you're doing great as well. Okay, Nimisha. Hi, Nimisha. Hi, Fatima. Okay. So I am getting a thumbs up from Arka, so I believe we are ready to start. Anvi has also given it. Hello, Anvi. I hope you're doing great. Okay, so let's begin and first check out all the concepts from this topic of integers. Okay, so these are some ideas that we've already covered, right? Like what are integers, odd and even, then integers, how do you represent it on a number line, opposite integers, multiplication using the number line, without the number line, and then change of signs, properties. So we will be covering all of these, and as I said, in case there is any doubt in any of these topics, feel free to type these out in the comments box. Okay, so come on, let's start off now. But before we do, I've got this important reminder to make sure you are joining the Telegram channel, because this is where magic is happening. All right. So all the revision questions, the session notes, the annotated session notes, so that these help you to revise later on. The Sunday Fun Day facts, you have your homework question, quizzes, all the session updates and notifications. You will receive it on the Telegram channel. You can find the link in the descriptions box for that. Okay. So moving on. I already have a doubt here. Sasmita says Bodmas, multiplication of integers, division and properties. Okay, please take my name. Marga Siddha. Look, I have taken your name here. All right, so we will be covering those topics that Sasmita has mentioned out. Okay, so let's start off in a quite basic way. Again, a good recall as to what are integers. All right, so first thing, let's check out what integers are. Now, to the set of natural numbers. Now, what are natural numbers? 1, 2, 3, 4, 5, on and on, right? They go on and on. To this, what we will do is first we will add the opposites of this. Like, let's say 1. The opposite of 1 is going to be -1. Then 2. The opposite of 2, -2. 3. The opposite of 3, -3. And the list goes on and on. Okay, but we also include the number 0 there. So all of these are going to be integers. Like if I were to properly represent it, okay, on let's say a number line here, you will have 0, 1, 2, 3, 4, 5, on and on and on. And then you will have -1, -2, -3, -4, on and on and on. So these are going to be your integers. And 1, 2, 3, 4, 5 goes on and on. They are going to be your positive integers. And then -1, -2, -3, -4, again, they are going to be your negative integers. Make sure you are thorough with the definitions. And 0 here is just going to be an integer. It's neither positive nor negative. Remember this. This is crucial here. Okay, moving on from the definition of integers to the next part, which is odd integers and even integers. Again, there is a crucial element to be remembered here as well. Odd integers, what are these going to be? Well, these are integers which are not divisible by 2. Like, let's say, for example, 1 or 3 or 5, 7. Even the negative integers will count here. -1, -3, -5, -7, -31, -45, 75. All of these here are odd because they are not perfectly divisible by 2. Even integers, on the other hand, are integers which are perfectly divisible by 2. What do I mean when I say perfectly divisible? It just means that when you divide an even number by 2, the remainder is 0. Like, for example, let's say 8. 8, when you divide by 2, how much do you get? 4. Right? There are no remainders out there. 16, when you divide by 2, how much do you get? 8. Again, no remainder. So these are going to be even integers. But you've got to remember that 0 is considered to be an even integer. Okay, so there are quite a bit of important points associated with 0. First thing, 0 is neither positive nor negative. 0 is going to be neutral. And the second important thing you've got to remember is that 0 is considered as an even integer. Okay, so hello, Ratna. the definition. 0 is neutral. Yes. Nimisha says, what are integers? Okay, Nimisha, we've already covered that. Positive integers, 1, 2, 3, 4, 5, 6, 7, 8, on and on and on. Negative integers, -1, -2, -3, -4. Again, they go on and on and on. 0 is also an integer. It's just that it is neither positive nor negative. And we've just covered what odd integers are and what even integers are. Odd integers, not divisible by 2. Okay, even integers, perfectly divisible by 2. All right, come on, let's move on now and check out integers on a number line. Okay, so this was, I believe, again, answers some of your doubts that you guys have still. Okay, so this is how we represent these integers on a number line. So you have 0 here, right? To the right side of 0, as you can see, you will have all your positive integers, and to the left side of 0 you will have all your negative integers. Okay, so as you can see, to the right side of 0 you have 1, 2, 3, 4, 5, 6. It goes on and on. So they are your positive integers. And then to the left side of 0 you've got -1, -2, -3, -4. Again, it goes on and on, and they are going to be your negative integers, and 0, as you can see, is neutral here. Okay, now using this you should also be knowing the integers which are big and small. Okay, like if I ask you between 5 and 3, which is bigger, of course, you will pretty easily answer this. You will know that 5 here is bigger than 3. But then if I ask you between -5 and -3, which is bigger, you should be knowing that -3 here is bigger than -5. Okay, between 0 and -1, which is bigger, of course, 0 is going to be bigger. The number which is on the right hand side, okay, that's always going to be bigger. Like let's suppose between -4 and -1, which is bigger. -1 is on the right hand side, so -1 here is going to be bigger. As simple as that. So this is how you represent integers on a number line. So I'm sure all of these concepts that we have covered so far, what are integers, even integers, odd integers, how do you represent these integers on a number line, are clear. If at all there is any doubt among these three, just type it out in the comments box, and we shall clear that and then move on to the next set of topics. Okay, so Nagendra says yes, Nimisha says yes, Janvi, so -1 is smaller than 0. Yes, Janvi, 0 is going to be bigger than -1, or another way of saying, as you rightly put it, -1 is going to be smaller than 0. Okay, Defina says, is there a Menti quiz today? Not math. Okay, if at all there is, you should be getting the notifications, so subscribe. All right, so Shruti says clearly understood. When will the next chapter start? After this session. This was, I believe, the last session for the topic of integers. As I said, consider this, the way we are progressing to be like building a house. Okay, integers will be the ground floor. And if the ground floor is shaky, it doesn't matter how many floors you build on top of the ground floor, the building is going to collapse in the end. So that's the reason why we want to make sure that all of you are in line with all the definitions and every property related to integers, because again, you will be using this in the topics that we are about to study next in algebra, other topics of numbers and so on. So that's the reason why we're making sure this is going to be the last, and next set of topics are going to begin after this. Okay, so no doubts. All right, let's move on to the next topic, which is going to be opposite integers. Again, this is going to be fairly simple. The opposite of x is going to be -x. Or let's say, let me just take an example of a number itself. The opposite of 5 is -5. As simple as that. The opposite of 7 is going to be -7. The opposite of 9 is going to be -9. So if I were to generalize it into an idea, the opposite of n here, n can be any number, is going to be -n. So this is again a fairly simple concept. I'm sure you've understood it. The opposite of 10 is going to be -10. The opposite of -15 is going to be 15. Okay, so I hope this is pretty clear. So let's move on to the next thing now, which is multiplication on a number line. So what is the opposite of 0? The opposite of 0 is going to be 0 itself, because as I said, 0 will not have an opposite, technically speaking, because 0 is neutral. 0, you cannot call it positive, you can't even call 0 negative. Okay, and it's only positive opposite is going to be negative, negative opposite is going to be positive. But that was a very good question. I'm really happy that you're asking good questions like these. +0 -0 does not make sense, guys, remember that. Okay, now multiplication on a number line. Okay, awesome. So 2 multiplied with 3, how are you going to visualize this? So you can visualize it like this, like 2 times 3. So you can think of it this way, like 2 hops are to be made 3 times. So this would be what? 2 times 3, okay, which is 6. And obviously you will be starting from 0. 3 times 2, which means 3 hops 2 times. So here's the first hop of 3 and the next hop of 3. Both are going to give you the same answer of 6 eventually. So this is how you represented multiplication on a number line. In case the number was negative, you would move to the left. If the number was positive, you would move to the right. Okay, fairly simple. Now let's move on to something really important, which is going to be these. I cannot stress enough on this. This is going to be the basic idea that you would use to simplify algebraic expressions that you shall be studying later on. So make sure you master them. Fairly simple to master any which ways. Same sign, the result is going to be positive. So positive multiplied with positive is positive. Negative multiplied with negative is also positive. Different signs, the result is going to be negative. Like let's take some examples. Like 3 multiplied with 2, both are positive. The result is going to be positive again. Minus 3 multiplied with minus 2, the result is going to be positive. By the way, even if you just write 6, it means it is still positive. Let's say one is negative, the other is positive, the result is going to be negative, and vice versa. One positive, the other negative, which means the same thing. The answer is going to be negative. So please make sure you've mastered this, because as I said, if I were to give you something like minus x multiplied, or let's just take numbers itself, I'm going to rub these out and try to give you a question which is a bit more on the challenging side. So minus 3, let's say you're multiplying it with 7 minus 2. Now one way to do that is to, this will come any which ways again later, but then the importance, I'm trying to stress it out here. You could do it this way. Minus 3, you could keep it as it is. 7 minus 2 is going to be how much? This is going to be 5. And you know the answer is going to be minus 15. But if, let's say, it is like this, minus 3 multiplied with x minus 2, you've got to be a little cautious here, because minus 3, when you multiply it with x being positive here, that is going to be minus 3x. And now this is crucial. This is where a lot of students make mistakes and lose out on important marks. Now this is going to be what? Minus 3 multiplied with minus 2. That is going to be plus 6. So that's the reason why I said it is crucial that you remember the same signs. When multiplied, the result is positive. Different signs, when multiplied, the result is going to be negative. Well done. Very good. Awesome. Let's move on now. The same rules apply to division as well. I don't need to stress any further on that. Same signs, when you divide, the result is positive. Different signs, the result is going to be negative. So 15, when you divide by 3, the answer is 5. Or minus 15, when you divide by minus 3, the answer is going to be the same, positive 5. Okay, because negative divided by negative is also positive. Whereas minus 15 divided by 3 is going to be minus 5. Or 15 divided by minus 3 is again going to be minus 5, because negative divided by positive or positive divided by negative, the result is going to be negative there. Okay, so far in all of the ideas covered, is there any doubt? If there is any doubt, let me know that in the comments box, and you know, we shall clear that before we move on to the next part of the revision. Okay, Milantha says, sir, what about subtraction? It's different rules. Subtraction, yes, we are coming to that. You know, that is going to be next. Yes, Janvi says, on subtracting minus 13 from 8, we get what? Okay, let me just write that down here for you, because subtraction is again crucial, and I'm going to pick up the question that was just asked, like subtract minus 8 from minus 15. Okay, now before we jump into this, you've got to understand the importance of the keyword from here. What if I ask you to subtract? Another word for, easy word for subtract is going to be what? Remove. Remove 3 from 10. How would you say that? Remove 3 from 10. So from 10, which means 10 minus 3. That's what you do, right? So same idea if I apply here, this is going to be what? From minus 15, I'm asking you to remove minus 8. Okay, so this is where you see minus multiplied with minus, we just covered it. That's going to be what? plus there. So this is going to be minus 15 plus 8, and then you know how to do this, right? Minus 15 plus 8 is going to be equal to minus 7. So operations involving addition and subtraction of positive, negative integers, I'm sure you guys are familiar with that. So this is what is going to be. And subtraction, be careful because the keyword from is going to tell you from what number you need to subtract what. Like subtract minus 8 from minus 15, this is how you frame it. From minus 15, you subtract minus 8, and make sure you do this modification, because minus multiplied with minus is plus, and then from here on this is going to be simple. Okay, why is it written different signs? Different signs? I'm not sure I understand that. Why is it written different signs? Where are you asking about that? Different signs. Could you please be a little bit precise? Second number first and then first number. Yes, good. But then think of it this way, okay? Whenever a difficult word problem comes your way, try to frame it in an easy way. Like remove 3 from 10, so 10 minus 3. Apply the same idea to this now. Subtract, which means remove. Remove minus 8 from minus 15. Same idea. Minus 15 minus 8. You just got to be careful of this thing, because minus of minus, or minus multiplied with minus, as you know, is plus. Okay. All right. Pradeep says, I'm very weak student in math. How can I improve it? Well, Pradeep, my only suggestion to you would be watch these videos carefully, because we are spending quite a bit of time on the concepts here. Once your concept is clear, just make sure you start with easy questions, okay? Absolutely easy ones first. They are going to give you some confidence, and then with that confidence, you shall be able to crack the medium level questions and then the difficult questions later on. But never start with difficult questions, okay? Always start with easy and then slowly begin to increase the difficulty level. That's what I would tell you, okay? So that's about it. Division, change in signs. I'm going to move on to the next topic here. Properties of integers. Now these are going to be interesting here. Closure property. Closure is very simple. First we will check out addition and subtraction, and then later on we will check out multiplication and division. So closure, what does closure tell us? It simply says that when you add two integers, if the result is another integer, then addition follows closure, and that works, right? No matter what two integers you take, like 3 plus 5, the result is an integer. Minus 5 plus minus 5 plus minus 7, the result is again an integer. So that's the reason why we say that addition follows closure, and in a similar way subtraction also follows closure, because when you subtract one integer from the other, the result is going to be an integer. You're not going to get something like a fraction or a decimal or anything else. Okay, so that's the reason why closure, addition and subtraction follow it. Now commutative, let me just rub these down here. Commutative. Now commutative means what? Again, this is simple. A plus B is going to be equal to B plus A, where A and B are integers, of course. So 3 plus 5 is going to be equal to 5 plus 3. 9 plus 10 is going to be equal to 10 plus 9. But then subtraction doesn't follow commutative. A minus B is not equal to B minus A, right? Like plug in some numbers and check it out. Like 9 minus 7, we know is not equal to 7 minus 9, because this is 2 and this right here is minus 2. So that's the reason why subtraction doesn't follow commutative property. Okay, and what is the last thing going to be? Associative property. And what's associative property? Let me just write that down here. A plus B plus C is going to be equal to A plus B plus C. So whichever group you combine the numbers and add, doesn't matter, the answer is going to be the same. Like 3 plus 7 plus 9 is going to be equal to 3 plus 7 plus 9. Both are going to give you the same answer. And again, subtraction doesn't follow that. The easiest way to verify is by plugging in some numbers in the place of A, B, and C and checking out if the equation is true. Yes. So this is about your closure, commutative, and associative. Nimisha says, what is meant by closure? Closure simply means this, Nimisha. If you are adding two integers, is the answer an integer? If yes, then addition follows closure. Okay. Same rule for subtraction. If you're subtracting one integer from another, is the answer you're getting also an integer? If yes, then it is following closure. You will understand that in a bit when I take the example of multiplication and division. As you can see, multiplication will follow closure. Like 3, when you multiply it with 7, the result is 21. So when you multiply two integers, the result is an integer. But that doesn't happen with division every time, because let's say 21 divided by 3. Well, yes, in this case it's true. But what if I divide 21 by 2? What I'm getting is 10.5, and I know 10.5 is not an integer, it is a decimal. So that's the reason why I will say that division does not follow the closure property. And in a similar way, multiplication follows commutative and associative. How commutative? A multiplied with B is going to be B multiplied with A. Simple. 3 multiplied with 5 is 5 multiplied by 3. 10 multiplied with 2 is equal to 2 multiplied with 10. Order in which you multiply doesn't matter. But division, well, it completely changes the game, right? 10 divided by 2 is not equal to 2 divided by 10, right? So that's the reason why division doesn't follow commutative and neither the associative. I'm sure you've understood what the associative is so far. Yes. So can't understand the difference between commutative and associative. Okay, fine. Easy way for you to remember. Let's rub all of this first. What do you mean by the word commute? Commute means what? You travel from one point to other point. Like, let's say you commute from your house to school, right? So commute is that word there, right? So let's say this is your house and this is your school here. Now you go from your house to your school. I can represent it like A plus B, A to B. Even if you go from your school to house, assuming you're taking the same path, then you're going to travel the same distance, right? So easy way to remember commute. A to B and then B to A. Is that clear now? Associative. There is a word association there, right? So which association means what? Partnering, right? So in that case, A plus B plus C. In this case, what are you associating together? You are associating B and C together. And this will be equal to A plus B plus C. You can think of it this way. Here, B and C are friends together and A is outside there. And here A and B are friends together and C is outside. Okay, so commutative, easy to remember now. Commute, home to school, school to home. A plus B is equal to B plus A. A multiplied with B is equal to B multiplied with A. Associative, brackets, association. Okay, I hope this clarifies the doubt now as to the confusion between commutative and associative. I used to have that when I was studying as well, and this is how we make up a few things through which it's easy for us to remember. Okay, Devyani says, what do we get? Okay, -7 minus 8 minus 25. Okay, let me just take that down before it goes away. -7 minus 8. So -7 is in the bracket, -8 and then minus 25. Okay, good that you've asked it. Let's try to solve this one together. -7, I will keep it as it is. Okay, -8 also as it is. But here there is trouble, right? Minus of minus, I know it's going to make that a plus. So these two are going to give me plus 25, because two signs, there is confusion, right? So plus of minus is going to be minus. Minus multiplied with plus is minus again. So minus multiplied with minus will make that a plus. And now, add it like your regular thing. So -7 minus 8, is minus 15. Minus 15 plus 25 is as simple as saying 25 minus 15. And as you know, the answer to this is going to be 10. All right. I am not discussing how to add numbers and how to subtract numbers, because I assume you already are familiar with that. That's the reason why I'm going through that operation a little faster here. What is the additive inverse of an integer? You remember what additive inverse of A was? Additive inverse of A is going to be minus A. Okay, so additive inverse of 5, minus 5. Additive inverse of minus 10 is plus 10, so on and so forth. Okay, those things are there in your textbook. I'm coming to the distributive property now, like one of the students have mentioned. Okay, so this is what the distribution property is, and it applies for addition and subtraction. Now you must be asking, where is the addition? This addition is here. Okay, subtraction, that subtraction symbol is here. That's it. Okay, now let me just show you how this is going to be useful, like we discussed in our revision sessions. Crucial in algebra. Okay, because when you're dealing with numbers, like let's say 3 multiplied with 5 plus 2, this is going to be simple. Even without distributive property, you can solve this. So this is 3 multiplied with 5 plus 2 is 7. You will say the answer is 21. Even without using the distributive property. But if you were to use the distributive property, this is going to be how much? Well, this is how you open the brackets, okay? 3 gets multiplied by the first number 5. You write that down. And then the sign in the middle is plus, so you take that. And 3 gets multiplied to the other number, which is 2. Okay? And this becomes what? 15 plus 6, and you get the same answer, 21. All right? But as I said, for numbers, even if you don't use distributive property, it's okay. But when it comes to simplifying algebraic expressions, it comes very, very crucial. Because let's say you had this x multiplied with 3 plus y. Okay, how would you do this? X gets multiplied with 3. So we simply write it like 3x. 3x simply means 3 multiplied with x. And then the plus sign in the middle. So I put the plus sign. And then x gets multiplied with y. So I write xy. All right, so that's the reason why distributive property is crucial. I have a problem in multiplication follows distributive. I hope this is clear now, right? Very, very simple. No big deal. Just multiply these two. A multiplied with B. You do that here. If the sign in the middle is minus, you put a minus sign, and then you multiply these two here. A multiplied with C, and you put that here. All right, so how to solve 30 multiplied with minus 23 plus 30 multiplied with 14. Same way, you first multiply 30 with minus 23. What do you get? 30. When you multiply it with minus 23, and then after that you have plus 30 multiplied with 14. So you multiply these two. What is 30 multiplied with minus 23? This is going to be 0, 9, 6. But positive multiplied with negative is negative. So minus 690 plus 30 multiplied with 14. This is going to be 0, 3 times 4, 12. 1 carry, 3 times 1, 3, 4. And you know how to do this, right? Minus 690 plus 420, you will get your answer. This is how you can do it, I hope all of this is pretty clear now. Let's move on to the next thing. Yes, additive and multiplicative identity. Additive, now there's a difference between additive inverse and additive identity. Okay, inverse means opposites. Opposite of A minus A. This is identity here. So don't get confused between inverse and identity. All right, so additive identity of A is 0, because when you add nothing to a number, the result is going to be the same number because you're adding nothing to it. So that's the reason why this is additive identity. A plus 0 or 0 plus A, you get the same A back. Multiplicative identity is going to be 1. Okay, because when you multiply any number by 1, the result is going to be the same number. So additive identity, make sure you write this down. There is a difference between inverse and identity. Additive inverse, additive identity. Do not get confused between these two terms. Additive identity of A is going to be 0. Multiplicative identity is going to be 1. Okay. All right. Moving on to the next thing now. This is fairly simple, dependent on the concepts that you've already covered before. Minus 1, when you multiply it with, let's say, plus 1, same rule, right? Plus multiplied with minus is minus. So that's the reason why you're getting minus 1. And what about this now? Minus 1 multiplied with minus 1 is going to be how much? Plus 1, because negative multiplied with negative, we know is positive. Now, you've already calculated this. Minus 1 multiplied with minus 1 as plus 1. So in the place of that, I will substitute plus 1. And now this becomes what? Plus 1 multiplied with minus 1, the result is going to be minus 1. And you can move on like this. So multiply these two, the result is 1. Multiply these two, result is 1. 1 multiplied with 1, the result is going to be 1. As simple as that, right? So let's say I give you this. Minus 2 multiplied with 3 multiplied with minus 5. Now, it doesn't matter in whichever order you're multiplying. Like you can multiply these two first. 2 multiplied with 3, 6. Plus multiplied with minus, minus. So this becomes minus 6 multiplied with minus 5. Now negative multiplied with negative is going to be positive. 6 multiplied with 5 is 30. That's all. So just make sure you are utilizing the signs that we've covered. Same signs, when you multiply, the result is positive. Different signs, which when you multiply, the result is going to be negative. Smiley face and sad face. Okay. Any doubts so far? Well, good job, guys. You are getting the correct answer. Okay, so shall we move on now? I hope all the ideas are pretty clear so far, and that's why we say we've got you covered. Last summary session for this topic of integers. You can watch this video later on in case there are any doubts in your mind, but make sure you are thorough with all the ideas. Practice some questions from this chapter, from your NCERT textbooks, from your NCERT exemplar. Watch the earlier videos if at all you get stuck anyways. But before we move on to the next topic, make sure you are absolutely mastering this. All right, any quizzes are gonna come later on, but not at this time slot. All right, so you know this, right? Summer break, we are planning some exciting activities for you. So what are these? Science projects. Now you must be seeing quite a lot of awesome videos being posted on the channel. So the science project, a fun way of learning science, the level up series, and the Explorers Club. So make sure you're participating in these and enjoying the content that we are posting it out for you, because that's a content that helps you in understanding concepts in a very visual way. Okay, and what we have next, again the same update, because this is really important. Make sure you guys are joining the Telegram channel, because I want you to receive these session notes, PDFs. These are going to be crucial part of your revision strategy. So make sure you join the channel. Last thing, in case you like the content that we're providing, hit that like button and share it with your friends. They will find it useful as well, because remember, sharing is caring. And the last thing, in case you still haven't subscribed, make sure you subscribe to the channel, and you will find the link for the free trial class. Utilize it. It is free. You've got nothing to lose, and you will come to know how you need to learn. And some students have mentioned it in the comments that you're weak with math. Maybe you need some personal attention. Maybe you need a mentor. You will get that. So utilize that free trial class that you have, because sometimes the only difference is you're not weak at math. Okay, you just need somebody to motivate you. We do the job here, but then one-on-one, it's a different ball game altogether. So make sure you utilize that, because all you may need, as I said, is a mentor who can give you all the necessary confidence that you need, and within no time you'll start getting better at math. I promise you that. And finally, I'd like to end this session with a big thank you. You guys have been amazing as usual. And until the next time we're meeting, make sure you're revising all these concepts, practicing all the questions from your NCERT textbook and exemplar. And we're going to have fun with the next topic. I'm sure of that. Take care and bye-bye.